All right, hello. So in this video, what we are going to do is talk about solution sets, how to graph solution sets to inequalities with two variables. Okay, so make sure you go ahead and title this Unit 3, Lesson 18, Solution Sets to Inequalities with Two Variables. Now, you've done this in class a little bit, but this video is just to help you with your homework and to reinforce what you already know and also clarify anything that you still have questions about. All right, so the system that we have here is y is greater than x minus 8 and y is less than or equal to 5 minus x. Okay, so just as a refresher, I want you all to recall that when we see the symbols greater than or less than, when we draw these lines, or not even lines, more like when we're drawing the inequalities, think of it as a boundary. Okay, so in this case, the boundary line would look like a dashed line. Okay, and that's only for greater than or less than. But let's just say that we had something like less than or equal to or greater than and equal to. That means our line or our boundary is going to be a solid line, right? Because this includes all the solutions on the line. So this just means all solutions on the line will make the inequality true. And then here for dash, if you want to write this is just means that any solutions on the dash line will not make the inequality true. So in this case, it's more as a boundary. So that way you all know that we're not including those points as part of the solution set. Points on dashed line are not included in solution set. Okay, let's go ahead now that we've clarified a little bit of that. It says graph the solution set of the system of inequalities. Okay, the solution set, remember, is for a system in this case are where both of the solutions cross over each other. Okay, so here you could say where both solution sets cross or intersect, or when the colors cross each other, can be a part of that. All right, let's go ahead and do this. So the first one that we have here, I'm going to do this one in green. We have y is greater than x minus 8. Okay, so for this one, I already know that I'm going to have, since it's a greater than, I know my line, I'm going to have more of a boundary line, right, with dash marks. But I need to go ahead at least plot these, my boundary lines, so that way I can figure out where to shade in my solution set. So here, I know that the slope is 1, right? So we know that y greater than x minus 8, you can think of the slope as the number 1 right here. And then I know the y-intercept is negative 8. So we're going to find negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So here's negative 8. And then my slope is positive, so I'm going to rise, run, and over run 1. So then rise, run, over 1. So right here. And I'm just going to make the little dashes here. Now, in my last video, I said that you all can draw it on a gray line if that helps you. But at this point, we should be able to recognize we can just kind of like sketch them out already as a dashed line. So then right here, we can go ahead and form these as dashes, like so. Great, great. Okay. And we can put our arrows. Sweet. All right, so this represents y is greater than x minus 8. So this dashed line represents this inequality, but we need to include the solution set. Now, you could think of this as this is y will always be greater than x minus 8. So you could just think of this as, oh, y has to be greater. I'm going to shade on the right side or on the left side. But if you're not sure, you can always test a point, okay? So let's go ahead and do that. I'm going to test 0, 0, because I like that point. So if I test 0, 0 and it works out, that means I should shade in that direction. So right here, I'll go ahead and substitute 0 and 0 minus 8. Is 0 greater than negative 8? Yes, it is. So that solution point makes sense. So we would shade in all of these solutions here, essentially. Okay, so all of this. Okay, so that's it. That's all we can do for right now. So then let's try this second inequality. So right here, we have y is less than or equal to 5 minus x. Okay, well, first of all, this isn't in slope-intercept form. So I'm going to go ahead and rearrange this so that way we can have this a little nicer for us. So we can write this as y is less than or equal to negative x plus 5. Okay, so that's the same thing. I'm just rearranging so we can see that a little better. So right here, this is also the same as y is less than or equal to negative 1x plus 5. So that means our slope is negative 1 and our y-intercept is positive 5. So we're going to go ahead and plot this inequality and its boundaries as well. So we're going to start with negative 5 or positive 5. 1, 2, 3, 4, 5. Here's positive 5. And then our slope is negative, so I'm going to go down 1 and right 1. I'm going to keep doing that. And here we go. More points, more points, more points. And the other direction as well. Okay, so this line, or this inequality, its boundary, since it's less than or equal to, that means I'm going to include all the solutions that it touches. So I'm going to do my very best to draw a solid line. Oh, and I'm failing, but that's okay. You have your paper and you should make it work. Okay, so this represents y is less than or equal to negative x plus 5. Okay, sweet. So, but we need to shade in the solution set for this one. Again, if this is less than, we would shade in below the line, but in this case, if you're still not sure, I'm just going to test the point, and that way we can see that. Okay, so I'm going to test 0, 0 and see what happens. Test 0, 0, and then we'll get 0 is less than or equal to negative 0 plus 5. Is 0 less than or equal to 5? 0 is less than 5, so therefore that works out. So I'm going to shade in or go in this direction. So all of this, oops. Okay, and so basically we can see that we have solutions here for y is less than or equal to negative x plus 5 for this inequality. But we see here, this is where they intersect, where the orange meets with the green. So that's the solution set for the whole system. Okay, so essentially, if I were to show this a little bit more clearly with my highlighter here, I would say all of this, okay, all of this, all of these points are part, or all of the solution set, or is the solution set of this whole entire system. Okay, so even though there's like some solutions here for the first inequality and some solutions here for the second inequality, those would not count because they are not a solution set of the entire system. So this is how we would shade our solution set. Okay, all right, so go ahead and write your summary here. Any new things that you've learned, you can include that there. But this, again, is a supportive video to help you with your homework in order to graph your own systems of inequalities. And good luck. Alrighty, bye.